Okay, let's finish up chapter 31 in this lecture, this recording. So we were, the last thing that we were learning about was homeostasis, and I told you that there were two ways that homeostasis is maintained in the body, and that is through a regulatory method called negative feedback and regulation by positive feedback. So let's look at how negative feedback works, because most conditions in the body that are maintained within a certain range are regulated by negative feedback. So what's being used here is an analogy of how our homes maintain the temperature in our homes. So what we have is we have a stimulus. In negative feedback, we always have a stimulus. In this case, the stimulus is that it is getting too hot in my house. So it happens a lot in the summer months. And there is a sensor called a thermostat. Well, there's a sensor on the thermostat. There's a thermometer that acts as a sensor. Okay, so the thermometer is the sensor. It sends the data to the thermostat, which is the control center. And the control center is set, so some people like it 68 degrees, some people set it at 70 and higher. I don't understand that, but all of us have a different set point. But in this case, the set point is 68. The temperature has gone above 68. So now the control center has to decide what to do. So there's two effectors in the house. There's either the air condition or the heater. So, or the furnace. So what the control center is doing, what the thermostat is doing is it's telling the furnace, which is our effector, to shut off. Another thing it could do is turn the air conditioning unit on. But in this case, it's just shutting the furnace off, and then that is going to cause our condition to return back to the set point, which is 68. Okay? Then let's say that we have the room is getting, or the home is getting too cold. Our set point is 68, but our thermometer that's connected to our thermostat, which is the thermometer is our sensor, is detecting that it's dropped to 66 degrees, which is too cold. That data is sent to the thermostat, which is the control center, and the thermostat directs the furnace to come back on, and it's going to cause the temperature to rise. So what we're doing is we have a set point, 68 degrees, and we're trying to keep the temperature very close to that 68 degrees. There's a range a little bit below 68, a little bit above 68, but go too low and the control center determines what to do about that, and you go too high, the control center determines what to do. So how does this work in our bodies? In our bodies, we also have sensors that detect if our body temperature has gotten too hot, and those sensors, some are in our skin. Those sensors send that data to the control center, which is our hypothalamus in our brain. The hypothalamus, if it's too hot, the hypothalamus is going to send information to effectors, such as, if it's too hot, it's going to send information to our skin so that we're going to sweat, and that evaporation of that sweat is going to cool our body. It will send information to our, directions to our blood vessels to dilate, carrying blood to the surface of our skin, and carrying the heat away, from the surface of our skin. The heat radiates off of our bodies, so our body temperature cools. And we also have a mechanism for if we do get too cold, we have a mechanism that our hypothalamus is always the control center, and it will tell various targets what to do to cause our body temperature to rise back to normal. So body temperature is definitely maintained by negative feedback. And here we go. I didn't even know. I should have looked. So this is the slide that shows you what happens in the human body. So we have the stimulus, the sensor, that lets our hypothalamus in our brain know, which is our control center, that our body temperature has gone above the set point of 98.6, causes our effectors, which are blood vessels, to dilate, our sweat glands to secrete, and that hopefully will drop our body temperature back to normal. When our thermoreceptors in our body detect that our body temperature has dropped too low, we've gotten too cold, the hypothalamus in the brain, which is around this area here, the hypothalamus is going to detect that, and it's going to send commands to our blood vessels to constrict, which will cause them to hold in the heat, and it will make our sweat glands become inactive. It'll inactivate them, and that should lead to our body temperature rising back to normal. So that's an example of negative feedback. There are a lot of other examples of negative feedback in the body, but that's a good one. Positive feedback is a little bit different, because in positive feedback, whatever the stimulus is, so when we were looking at negative feedback, so here the stimulus is temperature rises. Well, the response is to do opposite of that, to negate that stimulus. So temperature rises too high, the response is to cause it to lower, to decrease it. If the temperature does decrease, the response is to increase it. But in positive feedback, it's the opposite of that. Whatever your stimulus is, that stimulus is increased and increased and increased until the process is over. So childbirth is an example. Childbirth, the labor pains start out small, and then some chemicals are released like oxytocin, and they contribute to even greater contractions. That leads to more chemicals being released, greater contractions, greater contractions, greater contractions until the child is born. Some other conditions in the body that are maintained by positive feedback, I actually can only think of two. There is blood clotting. Your blood starts to clot, and then it clots some more, and it clots some more, and it clots some more. I mean, it just increases the clotting until your bleeding has stopped. Once the clot begins to form, chemicals are released that cause more clotting, more chemical released, more clotting. It's just increases the stimulus until the clot has formed. And then another one is milk production. So, and this one is the one that's showing you what happens with childbirth. It says, due to uterine contractions, the baby's head presses on the cervix and signals are sent to the brain, which is our control center. The pituitary gland in the brain releases oxytocin, and oxytocin increases those contractions, and it's a cycle. You have more contractions, more oxytocin, more contractions, more oxytocin, until finally those contractions lead to a baby being born. And that's going to wrap it up for chapter 31, focusing on the integumentary system, homeostasis, and tissues, and then make sure you know the names of the 11 body systems.